Find the absolute maximum and absolute minimum value of this quotient function over the interval -6 to 6. We need to find the derivative because maybe these endpoints, we are definitely going to plug in the -6 and +6 into the function, but we also need to plug in the critical values. Those may be the max or minimum, right? So let's find the derivative first, okay? And with this being quotient, this being a fraction function, I will use the quotient rule this time. I'm just copying down the problem down here, sorry. Okay, all right. So let's find the derivative q prime of x. Quotient rule says just square the original denominator. So the denominator is going to be x squared plus 4 squared. On the numerator, I start by writing the original denominator unchanged, but this gets multiplied by the derivative of the numerator. What is the derivative of 4x? 4. Minus sign. Now, after the minus sign, I copy down the original numerator the same, but this will get now multiplied by the derivative of the denominator. What is the derivative of x squared plus 4? 2x. Okay. Now back when we learned it for in the first time, we were writing down all the pieces. That still works. Do that. But I think, you guys been doing this for the last 10 weeks. You can probably do the quotient rule without writing down all the pieces. So I just wanted to do it a little bit quicker, okay? Now let's go ahead and distribute and simplify, okay? When I distribute this 4 in, I'm going to get 4x squared plus 16. And these two multiplied to be what? Minus 8x squared. All over the same denominator, nothing changed in the bottom of the fraction. But I think we can simplify that red numerator. All right, q of x equals. See, they have square terms. It's got 4x squared minus 8x squared. Let's subtract 4 minus 8 and get negative 4x squared. And then the denominator stays the same. Now, we got a quotient function for the derivative, and we now have to find the critical values, okay? Critical value for quotient functions happen when the numerator of the denominator is equal to 0. So look, I'm going to set the top of the fraction equal to 0 because that's when this q prime is equal to 0. But not just that, set the denominator equal to 0 too, because that's when this function is undefined. So I'm setting the top of the fraction equal to 0 on this side, and I'm setting the bottom of the fraction equal to 0 on this side, and we're going to solve for both, okay? So I'll do this one first. Subtract 16 from both sides. I get negative 4x squared equals negative 16. Divide by negative 4, x squared is equal to positive 4. Well then, x has got to be equal to plus or minus 2. So we got two critical values from setting the numerator equal to 0. Let's set this denominator equal to 0 and solve it. If you square root both sides, you will get x squared plus 4 equals 0. Because think about it, the inside of parenthesis better be equal to 0 so that we can do 0 squared equals 0. Now let's subtract and get that. Oh, look at that. We got x squared equals negative 4. If you square a number, that is not going to give you a negative number because squaring means you're multiplying either positive times positive, which is positive, or negative times negative. And what is negative times negative? That's positive. There's no way we're going to get negative 4 when you square a number. So this branch doesn't lead anywhere. It stops. There's no critical value because, we're not going to say the critical value is plus or minus 2i. Critical value's got to be real numbers, okay? So we got two numbers from this work. What were the endpoints? The endpoints were from -6 and +6. Now look at the values we found. Both +2 and -2 are in between these bounds. So we got 4 numbers to check. Because you see, remember the previous one that we did? We did all this hard work and got +4 and -4 for the critical value. But everything was out of the bounds. So we didn't really have to plug in so many values. But this one, we have to check all of these critical values because they are in this interval they gave us. So let us plug in some numbers. So I'm going to start by q of -6, which is 4 times -6 over -6 squared plus 4. Let's see how big that number is. Next, I have to do q of -2. So work is going to be the same. 4 times -2, -2 squared plus 4. Next, I have to do q of 2. 4 times 2, 2 squared plus 4. And then last one that I'm going to have to do is q of, I forgot, 6. That's going to be 6 times 2, 6 squared plus 4. And I will use a calculator for these 4, okay? I want to know which one comes out to be the biggest and the smallest. I'm going to a scientific calculator so that I can type these in, okay? So first of all, 4 times -6 over -6 squared plus 4. All right, let me move this over here. It gave me a decimal, guys. That's the one that I got. It looks pretty small. All right, next. You okay, Luna? Next one is -1. Oh dear. Next one is +1. Let's do the last one. Oopsie, not that one. Oh, Jesus, what did I do wrong here? No, it wasn't it wasn't too bad. I'm sorry. I was plugging these in and I noticed that I typed something wrong here. This is supposed to be 4 times 6. So glad I caught that. Times 6. And that comes out to be positive 0.6. Alrighty. So I can see 1's the biggest. That's the max. And I can see -1 is the lowest. That's gotta be the minimum. So I'm gonna write it down, but just because I made a silly mistake over here, I caught it, but I want to make sure that I got the final answer right by graphing it later. Well, let's fill in the blanks first. The absolute maximum value is 1. That's as high as it gets. And that happened at the x value of -2. I'm so distracted right now. I'm very sorry. +2. All right. The absolute minimum value is -1. That happened at the x value of -2. But it's okay. If I make a mistake, I'll catch it. I don't think I did. But let's go ahead and find the graph so that we can see if the graph matches our work. So on a graphing calculator, I'm typing in 4x over x squared plus 4. And I want to restrict the domain because I just want to look at it from -6 to +6. Okay? All right, let's see. So, this was just really nice. They mark these absolute maximum and absolute minimum point. And I can see the highest value is right here. And the highest value is happening at x of 2. And the y value is +1. So that matches our answer right here. The lowest value looks to be over here. And the lowest value is -1. And that's happening at x of -2. So we got this answer right. Okay. But I'm sorry about being little, I wrote the wrong thing down here, but that's as difficult as it will get for section 3.4. After this, we're going to look at just one more word problem example, but that's going to be for 3.4. And in 3.5, we're going to look at the application problems, okay?